Okay, so
Okay.
yeah, so same as before. It's gonna be an hour long mock. Actually, be about yeah, about an hour. It'd be about an hour long mock. In a real interview, it'd be about 45 minutes to 50 minutes of implementation time, which is what I'll give you today. And then usually afterwards, we'll do like questions, etc. I'll give you feedback, all that kind of jazz. Um, so let's get started then. For today's
Okay.
problem, I would like you to write me a function called sort. Well, actually, in Python, that's taken. Let's call it frequency sort. Okay, and it's going to take in a list of numbers, and I would like you to sort the list based on the frequency the numbers appear in the list.
Sort list by frequency in which they appear.
That's right.
Okay. So like if I'm given like one, one, two, two, three, then you want it, then I should output an array that's like one, two, three.
So
But in this case, we have like two numbers that have the same frequency. So then what do we do?
close. So not quite. We want to maintain all the numbers in the original list, right? So for example, if I may, we have a number like let's do
Okay.
2, 3, 4, 4, 4, 4, 1. I would like this list sorted in increasing order of frequency. And for tie breaks, you sort it by the natural order of the numbers, right? So we have three numbers that appear once, 1, 2, and 3. And because they all appear once, they need to appear at the front of the list. And the order in between, you decide which to put these numbers in, would be the natural ordering. So 1 is less than 2, which is less than 3, obviously. So I will like this in 1, 2, 3. And then 4 appears twice. It's the only number that appears twice. So it'll go at the end.
I see. Okay. So my initial thoughts are to create a hash map where you map the numbers to their frequency, and then we could just we could just iterate through the hash map and then append values with the highest frequency first. And then if we encounter values that have the same frequency, then we would check which one is smaller first.
Okay. Yep, that's definitely one way to do it. Yep.
Okay. Um, I'll call this def frequency sort that takes in nums, which is a list of integers, and then it returns another list of integers. Okay. Um, so I'm gonna create a hash map called counts, and then I will just loop through nums and add it to counts. So for okay, so then now we have a hash map that maps the number to the frequency, and then I think mm, I think like there's like a built-in function in Python where you can like sort by a given key. Can I
Mm-hmm.
do that or
Yeah, you can do
yeah?
that. Yeah.
Okay. Okay. Uh,
But do you,
Let
but do
me
you remember
think.
it?
Kinda. So it's like I don't know, like if I initialize a list, then I could be like uh counts dot sort. Actually, let me think. Maybe it's like sorted and then you pass in the hash map and then uh if you want to do like a custom key, you go like e equals lambda. And then we want to sort by frequency. So then it'd be like Maybe like that.
How
The
confident are you
key
in
would
that?
be like
On a scale of 1 to 10.
like 5. I don't know.
Okay. Then I'm gonna ask you to not use that and write it out. You can keep it there. We can talk about that, but I'm gonna ask you to write it out. It's not quite right.
Okay.
But I
Okay.
but I appreciate you trying. But I appreciate you trying.
Then I will manually loop through each of the keys and values in the hash map for key value in. And then, let me think. Like I want to get like the maximum value. Like I want to start appending the maximum values from this hash map first. But if I'm just iterating through the hash map, then I won't know where the maximum appears, you know?
Sorry, can you repeat the last the last thing you said?
Like I want to append like the highest values in the hash map first, but if I'm just iterating through the hash map
Uh huh.
pairs, I won't know like where the maximum appears.
That's true that we have it set up right now. Yeah.
Yeah. Um, hmm.
What if we don't have to worry too much about complexity first? Let's just get something that that's on the page and is correct.
Wait, what do you mean?
I'm assuming we're doing this for complexity optimization, like for efficiency. But let's not worry too much about that first. We're getting stuck. Let's just get something down that works.
Okay. Let me think. Okay, wait. So like at this point, if we're using like this array, then the hash map would look like uh 2 and 3 times 2. Okay. Um, mm, mm, could I like mm, I don't know, like what if I like pop all of these from the hash map
Okay.
and then store them as like a tuple and then mm, I don't know, kind of stuck.
Okay. Um, one thing we can so I mean one thing we can do is just build a list up, right? So we want to know if so for a simpler solution, right? So we don't worry too much about efficiency yet, but we want to build up the list such that our condition is met, right? So I mean the hash map's not ordered, obviously, um, but we can just take the first. We can just take some arbitrary key, for example, or we can take all of the numbers that have a same frequency and process those together, right? So for example, one thing you don't have right now, but one thing that we could also build is after we generate the the counts the counts of every number, is you make a separate dictionary which maps a frequency to all the numbers that have that frequency, right? So in that case we could have something like, for example, everything with frequency 1, we have, you can choose what type you want. I mean, I'll make it a list just for simplicity. We have 2, 3, and 1, right? Oops, and then there'll be some items with 2 that occur twice in the list, like 4.
Oh, okay.
right? And so if you were able to generate this, would you know how to proceed?
Okay. If we had that,
Yeah.
then I could just iterate through each key in like ascending order, and then I would process each of the values
Mm-hmm.
in its corresponding array in like ascending order and then append it to the result.
Mm-hmm. Yeah.
Okay. Okay, that makes sense. Okay, so then I will build the second hash map called frequencies. And then I will do for for key found in counts. I will noise if found. Okay, I think that works. So I'm looping through each of the
Mm-hmm.
pairs in the counts array, and
Yep.
then I'm checking if the value, which is not in there, and then I'll initialize it with the list and then append the key. Okay,
Okay. Looks good to
and
me.
then uh, okay, now I want to process this array in
Yep.
ascending order. So I guess I want to loop starting from 1 to whatever the highest key is, which I won't know, but
Uh,
because like I don't want to process the same key twice.
okay, yeah, that's true. But how would you process the same key twice in this case? I'm not quite sure of that.
Oh, uh, because like if I'm looping this, if I'm iterating just using this,
Mm-hmm.
then how would I know that it's in ascending order? Like, what if
Yeah,
this pair was like in front?
you wouldn't know if it's in descending
Yeah.
order, but you do know the keys of the dictionary, right?
Hmm.
So you have well, this is probably the right dictionary you want, but you have right. This is your frequency,
Hmm.
right? And here you I mean for your previous one, you know, let's just we can label these guys, right? So you did count dot items to get pairwise items. You could also do dictionary dot keys to get the keys of a dictionary. Would that help?
Yeah, I guess so. And then I could just check if the key is like one greater than the previous one.
Well, you would have so if you did, for example, frequencies dot keys, this would give you a list of keys. Now the list of the keys might be in the wrong order, but it will give you a list of keys.
Oh, true. Okay. Then, okay. Okay. Then could I just do dot keys?
You could, but that might not iterate through the right order. But you would get, but you would get a list of keys out. So it would be a list of it would be like this would be a list type. So if you wanted to, for
Mhm.
example,
Could I just like do like sort or
of course you could do anything you want. You could do sort, yeah,
okay.
yeah, okay,
So then that would give me the keys in sorted order. So it'd be
okay,
like one, two.
yeah, that's right.
Okay. Key frequency dot sort. So then I'm getting these keys, and then for each key, I want to iterate through the values of that key in this map. So then I'll do for for Okay. And then I will add these into this array. And then um, and then I could do this.
So hold on. So we have. So we're getting the values in
Mhm.
for all the frequencies, right? So
Oh,
this would be
wait.
this would be a list of 2, 3, 1, and 4.
Oh, that is not what I want to do. I need to get this, I need to iterate through just the list for the current key that
Yeah,
I'm looking at.
that's right. Yeah.
Yeah. Okay. Um, Key. I don't know if that works, but
Okay.
wait, like that.
Looks better. Okay.
Okay.
Right. Okay. So that makes sense. And what are we appending exactly? Can you be precise in this?
So we are looping through this array for like a given key, and we are appending each value
Okay.
in the list.
Okay.
And then I'm calling sort afterwards, which is
Okay. Is that
actually, wait, that does not make sense. I think that if I were to call sort, then it would sort the entire list, but I actually only want to sort the current like list that we're processing.
yeah?
Okay, then I could do like I could create a local list and then I will append to the local list
Okay.
and then I will sort the local list and then I will append the local list to this. Does that make sense?
That that makes more sense. Yeah. Um.
I
Well,
don't know if append is the right word. Maybe it's like extend because I don't want to append a list inside a list.
you're on the right track. That's right.
Extend.
Yep.
Okay.
Okay. And
Um, and then I want to return this at the end.
okay. Let's walk through the example we have. See how it works. See if there's any bugs.
Okay. So looking at this example, this is our input, and then I'm building this counts hash map. So I'm iterating through each number, and then I'm checking if it's not already in the hash map. I'm initializing a key to 0, and then I'm increasing the value. So then that will give us this. And then I'm building this array or this hash map, checking, I'm iterating through each pair in counts. I'm processing one pair at a time. And then I'm checking if the value is not there, initialize it with an empty list, and then append the current value, append the current key. Okay. I
And
think
can we
that makes sense.
so what will occur equal after this? Can we be precise about that?
Current, like this
Yeah.
list?
Yeah. So what will that equal? Yeah.
Uh,
You can sketch it out, right? So for example, you'd say it equals what?
okay. Um, okay, so I'm getting the keys from here. Okay, dot sort. So then assuming that this actually returns this,
Yeah, we can assume that.
then okay. And then for value and frequency keys, so for each of these, then I'm just appending 2, 3, 1. That's what's happening here. And then I'm calling sort, which will give me 1, 2, 3.
Mm-hmm.
And then I'm appending or extending it to result. So that will give me that. And then I'm getting this key, and then I'm doing the same thing, iterating through the values in that. And then at this point, this array will just have 4, and then I'll call sort, and it'll also be 4, and then I'll add 4. Oh, wait.
Is that right?
Oh, wait. Wait, no, that's not right because there's like 2 instances of 4.
Mm-hmm.
Okay. Uh, okay, let me think. Uh, so I want to iterate this many times, like whatever the value of the key is,
Okay.
then I want to append. Does that make more sense? So like since the key is like 2 in this case,
Yep.
I want to append the value for 2 times.
Yep, that's right.
Okay.
And so what would it equal now? Let's just finish the example. We're almost there.
Okay. Yes. Okay. It will equal this. Current will be like this, and then I will extend it like that.
Okay. That checks out.
Okay.
Any other concerns you have about the correctness?
I mean, this is like underlined, so I don't really know if that's correct.
That's not, but we don't have to worry about that.
Okay.
Anything else?
Uh, mm,
I'm not saying there is. I just want to check if you think there's anything else that's wrong.
I mean, I don't think there's anything wrong.
Okay.
I don't think so. I mean, other than the fact that it's inefficient, but
Okay, that's fine. I mean, let's talk about that. What's the time and space complexity of the solution?
um, well, for these 2 loops, it would be O of n because we're processing each number in the input, assuming n is like the size of nums. And then for this part, the outer loop is processing n times at most if we have like n different keys. Like if there's if all of the frequencies of the numbers are unique, then we would run this loop n times. And then I guess since there's another loop, there's like 3 for loops. So,
Yeah, there are 3 for loops, but it doesn't necessarily mean it's a bad thing.
true. Mm, mm, I think. Um, I think it would be n squared, but not sure.
Okay. And and just to clarify, right? N is the length of the input list. Is that what you're assuming?
Yeah.
Okay. Okay, so we're saying, okay, let's just put it at the top here. So we're saying time n squared. Let's talk about the space then. What do you think the space is? The space complexity?
Base would
Yeah.
also be O of n squared because we're building hash maps, and at most we could have like n different keys.
Yeah. You have 2 hash maps here, and they both
Uh-huh.
could
And
have
then,
at most in different keys. Yeah, I agree.
yeah, and then in here, we're also building like local arrays, but at most they would contain n items in the array as well. Same with the result list.
I agree, right? So these two can be at most length n. This can be at most. I mean,
Mm-hmm.
this is length n because this is like what it's meant to be. This you're
Yep.
also saying can be at most length n. So what is the overall
Yes.
space complexity?
O of n.
Okay. I mean, you changed your mind really quickly on that.
Wait, what do you mean?
You said it was n squared. Now you're saying it's n. Which one is it?
Wait, no, I said the time
Okay,
complexity
okay,
was n squared.
okay, okay,
Yeah.
okay. That's fine. We have more time left, so I want to just move on from this for now, and we'll come back to it in this discussion after. Let's
Okay.
try. Okay, so let's try a different problem now. Um,
Sure.
So we can just go underneath this. So this is
Okay.
sort of switching gears to this different problem. In this problem, I want you to write me a function called validate. Okay, and it's going to take in a node for a binary search tree, and I would like you to return true if and only if the binary search tree is a valid binary search tree.
Okay. 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 Let me think. So, just to reiterate, we are just getting one of these tree nodes as input, and then I have to traverse this tree and determine if it's a valid binary search tree.
You're getting the root of the binary search tree, and yes, that is correct.
Yeah. Okay. Okay, let me think about this. Hmm. Wait, so just to clarify, a binary search tree is when the root node is greater than two of its children, right?
That's a heap. For a binary search tree,
Oh,
the
right, okay.
condition is that the left subtree, so the current node's left value, is less than the current node's key, than the current node's value. Sorry, and that the current node's right value is greater than the current's value, and we can assume there are no duplicate values in this tree.
Okay. 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 Um, so, uh, what I'm thinking is, hmm, so what if I were to recursively traverse this tree and check that the root node is greater than the left child,
Mm-hmm.
but smaller than its right child?
That sounds reasonable.
Okay. Hmm. So, okay, let me draw this out. So if I have a tree that's like, maybe I'll make this like, so this would be a valid binary search tree because the 3 is greater than the 2 and the 2 is greater than 1, and then these numbers are also greater than each other. Okay. Okay.
Yep.
Um okay, what if I do like a depth first search on the tree, and then once I reach like a root node or like a leaf node, then that means I'm at the bottom of the tree, and then I can return back to the parent node, and then I would check, uh, wait, let me think. Would check if, okay, I'm like, I don't know if I should be traversing this like depth first search or breadth first search, because if I do breadth first search, then I have to keep track of like the order of the nodes. Okay, let
Yeah.
me think.
Before
Uh,
we go too much into that path, maybe there's one more thing I wanted to check on, which is another example. So let's say we had this example here. Um, would this be a oh this would be duplicate? Would this be a valid binary search tree?
no,
Okay.
because this one is like smaller than this.
Yeah,
So
that's right.
it's on the right side of the tree, which, okay.
No, that's right. Okay, well, I just want to clarify that. And then one more thing, maybe just to get us started on the right foot here is right. So thinking of depth first search makes sense. That we could definitely do that. But just to clarify, right, we're not searching for things. We're just we're just traversing the tree, right? What kind of
Yeah.
traversal? Like what kind of traversal are we performing to do to validate a tree in this context?
Uh, mm,
Do you remember your traversals for trees?
Reorder, in order, post order.
Yep. And what are the characteristics of each? Which one should we do here?
Okay. So in order would be like I'm processing the left child, the root, and then the right child. And then pre-order would be I'm processing the root, the left child, and then the right child. And then post order is like left, right, root, I think.
I think I got that right, but yeah. Which of those do we want to use? Which has the right
Um,
characteristics for a binary search tree? Right. So don't look at this. I mean, this is correct, right? So don't look at that one anymore. That one's not helpful. Right. We're looking at this.
okay. I mean, I think we want to do in order traversal because then we would be processing the nodes in ascending order, which might make sense.
That does make sense. That does make sense to me, right? We want to
Okay.
check that
Wait,
all the
okay. Yeah. Sorry,
okay.
go ahead.
Well, I mean, like, right. So to validate it's a binary search tree, all the nodes in the in order traversal must be ascending.
Yeah, okay. What if I do like an in order traversal and then I append all the nodes into like a list, and then at the end I could just check if the list is in ascending order? Would that give me the correct result?
That should give you the correct result. Yeah.
Okay, I think I want to try that.
Okay, let's do it then.
Okay. Def validate free take in a root. So, okay. So to do the in order traversal, I'll initialize a list like that. And then I will, okay, maybe I'll initialize like a helper function that will take in a node. And then I have to check if the node is not there, if not node, return. Otherwise, I'm, wait, so in order is I'm processing the left child and then the root and then the right child. So then I process, then I go like helper dot, helper node dot left, and then I append node dot val, and then helper node. Right. I think so. Like I'm processing the left child,
Mm-hmm.
and then I'm getting the root, and then I'm processing the right child, and then returning this list. Okay. And then, okay, so I'm going to call this function with the root that's passed in this outer function. And then I'm going to get result equals this. Okay. Okay. And then I need to check if this is in ascending order. How do I do that? Let me think. I guess I could just like iterate through this list and like compare adjacent values and then check if the right value is greater than the left value. Does that make sense?
Yeah, that's one way to do it. There's many ways to check a list, but you can definitely do it that way.
Okay. Okay. So, okay, I'll do for I in range length of resolve. So I want to check. Okay, so I want to check if I is smaller than. Oh wait, actually I'll do if the current number is greater than the next number, then return false. And then otherwise return true, because then we've traversed the whole list without encountering this condition. Um,
Okay.
would I go out of bounds here?
You tell me.
Because, okay, if the list is like, okay, say the list is like uh, 1, 2, 3, then I'm iterating 2 times. Then the first pass, I'm comparing 1, 2, and then I'm comparing 2 and 3. Like, I think it's fine. I think it's fine.
Okay. Do we want to walk through an example? You can use your example tree.
Oh, sure. Okay. So I'm passing in the root, which is 3, and then I'm calling this helper function helper, and then I'm checking if the node is null, return. Otherwise, I process the left child. So then I'm processing 2, and then I'm processing the left child of 2, which is 1, and then I'm trying to process the left child of 1, which is not there, so then I return, and then I append. Okay, I'll make my result list. So I append 1, and then I'm going back to I'm going back here, and then I'm processing the right child. There is no right child, and
Mm-hmm.
then I append this 2, and then I'm processing 3, and
Yep.
then I'm checking if 3 has a right child. Wait, no, I'm first appending 3, and then I go on the right child 4, and then 4 does not have a left child, so then I append 4, and then I look at the right child 5, and then I append 5, and then 5 has no left children or right children, and then I return this list,
Mm-hmm.
and then I'm processing this list here. Okay. And then the range would be 0 to 4. And then I'm checking if these two numbers, so that would be the first iteration, 1 and 2. And then I'm checking 2 and 3. And then I'm checking 3 and 4. And then I'm checking 4 and 5. So 4 iterations.
Yep. Yep. Looks good to me.
Yeah.
Time and space on this one, please.
Okay. Let me think. So this helper function will process all of the nodes in the input tree
Mm-hmm.
once. So then that would be O of n, assuming that the size of the tree has n nodes. And then here I'm also looping through this result array, which will have all of the nodes, so n. So then it would also be O of n in terms of time complexity. So it would be O of n. And then the space complexity, let me think. I think like for this recursive function, the the stack trace would be the height of the tree, I think on average case, but like if the tree is unbalanced, then it could be the size of the whole tree, which is n. But on average case, it'd be the height of the tree. And then for this loop, we're iterating through. Oh, wait, then, but if I'm counting this result array in terms of space complexity, then it would be O of n.
So what's the total complexity? Space?
O of n.
Okay. Okay. Sounds good. Let's wrap it up and talk about some things about both problems. Right on time too, actually.
Okay.
About 45 minutes. Cool.
Oh,
Okay,
nice.
so I mean, I like to generally ask you guys, how do you feel first of all, right? What's your confidence level? How well do you think you did in either
Uh,
problem?
I don't think I did that well. Like, well, for the first problem,
Okay.
I feel like I had like good intuition in what to do, but like I did not know how to implement the functionality. Like I forgot how this sorted thing works,
Okay.
and I kind of got stuck during this part.
Yeah.
But I
Okay.
feel like that's more of like I just need to practice writing more code. But like I think I had good intuition about the problem.
Yeah.
And then this one, same thing, I guess. Like I was a bit stuck on which direction to go in the beginning, but I
Yeah.
mean, I feel somewhat confident with the solution, I guess.
Okay.
So I don't know.
No, that's good. That's good. I think that's a pretty accurate assessment of generally what an interviewer would feel. But we can break it down a bit, and in a bit more detail. Do you
Okay.
want to talk about the first problem first?
Yes.
Okay. So I mean, I guess the first thing to say about this one is like, yeah, the I mean, using the sorted function is typically what people do, especially on Leetcode. But this is exactly why you can't just practice on Leetcode, right? Right? Because if you're on Leetcode, you go search out, oh shit, what's the hell? Like what's the key? What's the lambda? You
Mhm.
can't do that in real interview, right? So if you don't know it,
Right.
you don't know it, right? You can't just say, oh, and then this is how it
Yes.
works. No, that's not how it works, right? And also the way you have it set right here wouldn't be correct either way, even if the syntax was correct, because this doesn't do the tie breaking correctly, right? So
Right. Like I would need like a second condition to account for that.
yeah, you were actually pretty close to. I mean, to be honest, right? So I'm not sure if you're aware. So do you use Python for stuff outside of LeetCode as well?
No.
Okay, so that's probably why I didn't know about the breaking condition. So it would be like this. It would be X. This is how you would do it,
Okay.
right? But if you didn't know this, you can't use it.
Would you recommend like doing this for an interview, or is it better to like manually
It's
do
it's
it?
always better to do this because that's optimal, but most interviewers won't let you do this unless you can explain exactly what's going on.
Okay, yeah. Because I feel like I would not be able to like memorize this, and like if the conditions are like slightly different, then I would not be able to come up with the lambda function.
Yeah,
So,
and I mean this is another thing which is a really common thing I see because I'm an interviewer, so I see a lot of people come in with these kind of not this problem obviously, but like different problems with lambdas and all that jazz. Um, One tip I'll just give just in general is obviously if you can use Python and more things, you can get more familiar with it. That's great, but a lambda is just an anonymous function, right? And so you can define a
mhm.
helper function yourself, and that can give
Oh,
you and that would be something that you can do. So for example, you could do like
oh,
this,
okay.
uh, def help, call it like get index or get key, or let's call it helper, and then you do your logic over
Hmm.
here. So uh, x logic, you do actually it would be ab. So
Oh, okay.
return compare ab, and then you would just put it over here. Helper.
Oh, like you would
So
just put the function name. Oh,
yeah.
okay.
So lambda is an anonymous function. So that's one thing you can do. If you're not sure the syntax, you can do it this way, right? But you still have to know that, right? So, right. So let's not dilly dally on that. generally speaking, there should be a signal for you to realize that like don't lean on that too much, because if you don't practice more, you're not gonna remember. Like you're just not gonna remember all the lambdas. You're not gonna remember all the things about the some other tips and stuff, right? So be ready to actually write out all the logic yourself as well, and I think that's a pretty good form of practice just in general.
Okay.
Okay, so that's just one thing. The rest of the problem is actually done quite well. Obviously, you got stuck a bit on how this kind of thing works, like in terms of like a more
Yeah.
basic algorithm. So, and I mean, like this is not like a common algorithm you'll see. Like this is a pretty contrived problem, but I mean, most of these problems are contrived, and so it is up to you to kind of think of what the best way forward is, right? But I will say at least is that you were good and that you recognized that you were not making progress, this is not going well, and to ask for help. Um, Most interviewers in that context would at least give you something to kind of go off of. So, like if you feel like you really are stuck, that's not an issue to kind of look for.
Okay. Did I come like I'm assuming this is not the optimal solution, right? Like,
It is the correct solution given that you're not using this, but yeah, it wouldn't be
oh,
optimal.
okay.
Yeah. Um, yeah, and we can talk about this as well. So there's another reason this isn't optimal, and this is something which you didn't quite catch on the playthrough
Oh,
again.
is it the sort?
Yeah, it is a sort, but not exactly in the way that you thought of it. So, and this is like pretty deep arcane knowledge, so don't get too caught up on this, right? But it's not efficient to sort over here. Why is it not efficient? It's not efficient because cur has already been expanded with the duplicate keys. It's more efficient to sort before you duplicate the keys, right?
Oh, you're right. Yeah, that's
So
true.
so that's one thing, right? So you didn't catch on the second way around because in the example I only gave you two, and that's at the end. So it's not obvious, but that is a thing, right? Um, Other than that, it's
Okay.
fine. I will also say that in Python you should be using the counter whenever you can. The counter is super 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 useful for basically a
Oh,
whole
okay.
category of
I don't
problems.
know. I just assumed that you'd want to see me write it out, but
I'd
yeah.
say nine out of 10 interviewers literally don't care. One in 10
Okay.
will care, and they'll just tell you, and you could always ask, right? Because
Okay.
it's I mean like I'll put it this way, right? Like you're not using count over here, but you're using sorted over here. Like what's that? What kind of reasoning is that? So always lean
That
on
is
you can
true.
always lean on using counter. Just say, hey, I'm using counter. Is that okay? Do you want me to write this out? Right. Worst case, to write it out, you just write it out. Right. It's not hard, but it can save you time. Right. Um,
Right. Okay.
and detail, let's say, and I don't like talking about Python all the time because it doesn't really matter. But like if you're using Python things, you kind of have to know it, right? So like for example, sort is a function on ordered sets, right? And so if it's not an ordered set, you can't use dot sort. Instead, you should use this sorted processor, which takes an any iterable, right? So this is how would have been actually correct to use, because keys,
Oh.
um, it's an unordered set of it's an unordered key. It's actually a special type called dictionary keys, but don't worry about that, right? Now that won't fail the interview, but they'll know that you don't actually use Python, right? So for example,
I
if this is for
see.
a role where they actually say Python experience, right, that might be more of a yellow flag. But I'm just letting you know, right? Most people won't care, but if it is a Python role, they'll be able to tell, right? So just keep that in mind.
Okay. Okay.
One more
Makes
thing to say
sense.
about this problem is that the time complexity analysis is sort of correct, right? So this is O n,
Okay.
this is O n, like no one cares about that. What's going on here, right? So you are right in that. So this could be worst case in, and this could be worst case in, right? But
Uh-huh.
they can't both be worst case in. That's the key insight, right? If you have in keys, right? That means, or okay, let's say you have almost in keys. So maybe like in minus a constant number. So like not in divided by two, but like in minus like let's say 10, right? That means this has to be constant space, constant time, right? Because you
Hmm.
can't have in different keys and for each key you have in different numbers,
Right.
right?
Yeah.
That's not
Yeah.
possible. So only one of these two can be in at a time. Does that make sense?
Okay. Yeah, that does make sense. So then overall, would it be n squared?
Well, so in your case, it would still wouldn't be good because you have a sort
Oh.
over here. So right, so still it wouldn't be in square. It'd be better than that. The analysis would be a bit more advanced, but it would still be proportional to n. It would still be proportional to linear time. Um, but I will say this is very, very, and this is where the difference makes sense, right? Right now, if you're saying the analysis is n squared, it doesn't matter where the sort is, because the sort is at most n log n, which is obviously less than n squared. So I don't care about that, right?
Yeah.
But if you're saying, okay, only one of these can be n at a time, which means that this is proportional to n, then it does matter where the sort is, because then then the n log n can dominate the n. So like just be prepared. One thing you should always keep in the back of your mind, and it didn't happen today, but one thing you should keep in the back of your mind is if you're updating your answer for what the time complexity is, make sure that you actually make sure in your head that you have all the notes down for what's going on, right? So I have a tip for this. Generally speaking, if it's not trivial, what you should be doing is for every loop, you should be writing the complexity, right? So for this one, just write, oh, this should be O.
Okay.
So I won't write the
Okay.
right. This is n, right? So this is counts. Counts is proportional to the number of keys. Obviously, worst case it's n, so that's n, right? So this one you should also write n, right? This is n because it can be at most it could be n keys. Also, by the way, it's actually a bit more than n because it's sorted, right? So this is already gonna be n log n, right? But what's going on over here? So this is where you would keep in track, right? So for example, if you say for Valen, this can be at most n, right? So this can be n, but only one of these two can be n, right? At most n. So this is how. So for example, you say, oh shoot, this is actually, let's just say this is like k or something. Oh, then now this is bigger than k. Then I got the answer, right? So I recommend writing these things down just as quick notes. And so later on, it's easy to reference. And also, if they change requirements of the problem as a follow-up, it's easier to see. Right.
Okay. Yeah,
So-
that makes sense.
So this is something which you should probably adopt. Anyways, and yeah, in this case, it would be extend. Extend is correct. Right. Append would have done what you said. It would have added the array as an item in the array, so that would have been good. But extend is
Okay.
correct here. Yeah. Okay.
Okay.
Wanted to have a bit of time talking about the second problem as well. So let's move on to that one if you don't mind.
Yeah, sure.
Okay. So this one, this is all about traversals, right? This is basically testing how well do you know your binary search trees. And whenever someone's talking about validate, or whenever someone's talking about a problem where you need to visit every node, right? So validate, search you might not need to validate, search you might not need to visit every node, right? But for the validate or find min, find max, right? These things you would need to visit every node, right? Okay, maybe for a binary search tree for a find min, but like a general tree, find min, find max, you would need to visit every node. And so whenever you have a problem where you need to visit every node, the problem is about traversals. That's the entire problem,
Yes.
right? So how do you know your
Okay.
traversals? In this case, I have to give you a bit of a hint to guide you towards thinking about traversals. But once I told you that, it was correct afterwards, right? So you knew about the in order,
Yeah.
and you knew about pre-order, post-order, that kind of jazz. That's great, right? So you were actually pretty fast in kind of making writing the traversal. That was good. A bit of a hiccup on the validating ascending. You didn't seem very confident in that. Was there a reason?
I don't know. I guess I don't really do that very often. Is it wrong?
No, it's right, but you were very
Is
hesitant.
this like efficient?
Yeah, this is fine. This is efficient. Yeah.
Oh, okay. Is there a
Um,
better way to do it? Like, I wasn't sure if this is like too brute force.
there is a better way to do the problem, but not a better way to validate if an array is in ascending order.
Oh, okay. I just wasn't sure if this was like the most efficient, but I guess looking back, I wouldn't know what other way to do it. So,
Yeah, no, this is fine. It's fine. It's just that it was a bit weird that you were, you banged this out real fast. That was good, and then this took almost as much time. I was a bit concerned, like, oh, did she not know how to do that? So this is a bit weird. So calling that out, right? Like, if it's just lacking confidence, you should have more confidence. If you're actually not sure how
yeah,
to
I
check
think
this,
it's like lack of
okay.
confidence.
Yeah, so if you're ever lacking confidence, just run your own example, right? Run that through. Now,
Okay.
so I will quickly comment on the more common one is typical is that like you don't really need to have an entire array of results. If you think about it, you only really need the previous number, right? Like
Yes.
whenever you're about to add to the array, don't add to the array. Just compare the previous value with the current value.
Okay. But then I gotta like pass in like the previous value, right?
Well, you don't need to pass anything. You can just sort over here, right? So imagine, right? So here you would just check, right? So if priv val is not how do this? I just like this, right? If it's there, then you just do compare. So if no.val is, how does this work again? So this is, so we're always traversing increasing order. If no.val is less than priv val, return false, right?
Oh, okay.
Else priv val equals no.val.
Oh, I see. Okay.
Right. So you don't really need to store the entire list when you traverse the array. You only need to know the previous number. That's all, right?
Mm-hmm. Yeah.
Yeah. So that would have brought your space down to be more efficient.
Okay.
But it still wouldn't be O1, right? Because you would still have, like you said, you would still have the stack and the call stack, right? And you were correct in that analysis in that so you were correct, but your wording was actually not quite correct. Like the answer was correct, which is that it's proportional to height of the tree. But I forgot how
Uh-huh.
you phrased it. But the way you phrased it made it sound ambiguous. No, it's not ambiguous. The call stack, or aka the space complexity, is always proportional exactly to the height of the tree. It's not, it doesn't depend if the tree is balanced or skewed. If it's skewed, the height of the tree increases, right? So it's always the height of the
Oh,
tree,
okay.
right? And so,
Yeah,
so,
I
so
guess I just like I was trying to say that like if it was unbalanced, then it would be like O of n, but it's like O of n would be the height of the tree. So yeah,
yes, yes,
I
that's
should
yeah.
have just said that.
So that's right. But the way you said it was correct, but not accurate, not precise, right? So, but I think
Okay,
it's correct
yeah.
the way you analyze it, right? If it's a balance, if it's a binary search tree, if it's a balanced binary search tree, then it'd be the height, which would be log of n, right? But if it's just any binary search tree, then it could be worst case O of n, which is what you said, which is what you wrote, but not exactly what you said. But otherwise, it was correct.
Okay, yeah.
Uh, okay, cool. Anything else before we wrap up?
Uh, no, not really. Do you have any like overall like feedback for me? Like, is it just like
Yeah,
the technical skills that I need to improve on?
I think the biggest one is just about practice, and not just doing more practice. What I mean by that is like when you're practicing on Leetcode or whatnot, like practice in the mindset of doing an interview, right? So what I mean by that is, of course, set yourself a timer, figure out what's going on there, right? So you have a time management kind of thing going on, right? Because that's when the people get lost on pretty easily. And the second thing
Hmm.
is don't use any help. Don't go online. Don't do anything, right? Just if you can't,
Okay.
if you forget the syntax, too fucking bad. Do something else, right? Like most of the time,
Okay.
like that, like you can't be caught up on that kind of stuff because that's not a crutch you can lean on. Um, like you can't lean on that, right? If you don't know how the lambda keys work, you can't use it. Or what can I say, right?
Hmm.
So
Yeah.
so and that's just, so it's not just that. It's also like, oh, I'm not sure the complexity. Well, too bad. Write it down. Write down what you think it should be, and then check it afterwards. Right? Don't like, oh, I'm not sure. Oh, let me just go search up the complexity of a DFS. No, no, no. Write it down. Like do what you do in a real interview, and then check it afterwards. Right? And then if it's wrong, then you should figure out, oh, why was it wrong? What did I forget to take into account? So what I'm
Mm,
getting is, I
okay,
think I
yeah,
think
that
the
makes
practice
sense.
is fine as is. I don't think you should increase the volume necessarily, but it's just that what you do when you do the practice is, can be changed as well. So just something to consider.
Okay, cool. Thanks. That helps.
Okay, take care.
Okay, thanks. See you.